Hello everyone and welcome to my YouTube channel. Today we are going to start the second module of the GenAI series where we are going to start Retrieval-Augmented Generation, also known as RAG. And since this is the first video, we are just going to see what is RAG, why it matters, and how it works. All those things in this video. And in the next video, we'll cover the rest of the topics inside RAG. If you are new to this channel, I will quickly tell you I have started a GenAI and RAG series where I'm teaching everything about GenAI and RAG AI agents from scratch. We have already covered the first module where I have covered everything about OpenAI API. Then we are going to cover RAG. Then I'll cover AI agents, RAG evaluation, and a lot more. So make sure you subscribe to the channel to watch this series. And now I think we can start the session. Let's see what all we are going to cover in the session today. We are going to start with what is RAG, then why RAG, why GPT or the OpenAI API is not enough, problem that RAG solves, real world use cases of RAG, and then at the end, we'll also look at how RAG actually works. If you are not aware of what is OpenAI API, you can look at my previous video. Make sure you watch that first before watching this because I will take a reference from those videos multiple times in this video. Let's start with what is RAG. I'll show you with a simple example. Let's say I found a paper about evaluation report on MCP servers, something random written by someone unknown. Okay, and this is a recent paper. If I ask about this to ChatGPT, can you give me the executive summary of this report on MCP server? Because ChatGPT is trained on a huge amount of data, it is confused now which report I'm talking about. It doesn't know it's about this. Maybe it will generate a generic answer or it will ask you, I don't know which document you're talking about because this might be a new document. So it will not be able to answer that. So what I did next was I uploaded this PDF and then asked the same question. Can you give me the executive summary? Then it was able to answer it quite correctly, right? So what happened behind the scenes? OpenAI used this technique called RAG to answer my query. If you look at the first input, it is not aware of this context. It doesn't know which thing you're talking about. But then what I did was I provided it some document that read this PDF, maybe something else PDF, maybe PDF 3, 1, 2, 3, and then give me the answer for this query. Then it was able to understand that, okay, this is the context and this is what I have to answer. And it was able to generate a good output for me. What OpenAI used behind the scene is this technique called RAG, which we are going to discuss in this session in detail. We'll also look at how it works, why it is so important and everything. So make sure you watch this video till the end. Now, what is RAG? What do you understand from what all we have covered yet? What RAG is nothing but making your LLM aware of your documents. You have some documents, let's say any PDF, docs, web page, anything. You want the LLM to answer a query using your documents, right? Then this is done using RAG technique. That's it. Now, what do you think can be the advantage of using RAG technique? If I'll ask a generic question, right, and if I'll not give OpenAI API or any LLM correct context, it can hallucinate. It can print any random answer that, okay, it maybe someone else has written something else. It will give me random anything output, right? Which we can avoid using if we are using RAG. We want it to answer specifically from our document, which reduces the chance of hallucination. What else can be the advantage of using RAG? First thing we saw that it reduces the chance of hallucination. Second is you get specific answers, right? Third is you get answers from your own documents, right? Now, the next thing is, why would someone want these advantages? Why RAG is becoming so popular and why someone will want all these things? Okay, let's try to understand that with a real world example. Let's say you are Amazon, okay, and you are building a chatbot, okay, to help your customer answer their queries, right? They have some query, they will come to your chatbot, they will type, and you will use, let's assume you are using OpenAI API to answer their queries. Okay. Now, let's say a user asked a query, can you give me the cancellation? Can you tell me more about the cancellation policy? What will happen? OpenAI API doesn't knows about the cancellation policy at Amazon, which is different at different organization. It will print a generic cancellation policy that we have a cancellation policy that looks like this. But as an organization, would you want to return a generic cancellation policy to your user, or you want specific cancellation policy? You will always want specific cancellation policy, right? So that's why if you are building this, you will use RAG technique and you will give it access to all the docs where cancellation policy, policy 1, policy 2, policy 10, everything is written. And then you will build a chatbot on top of it using RAG such that when someone asks for cancellation policy, it can read from this cancellation policy and then answer that specific query. So this is why enterprise companies, they want their chatbot or their AI to answer queries on their data. They don't want to see a generic data. Like if there is analytics company, they want to show their analytics, not any generic analytics, right? Some other organization will want their data to go into the chatbot and then generate the answer. And if you want to do that, you will use this technique called RAG, which we are going to learn in this module. Now, if I have to talk about the real world use cases of RAG, there are multiple real world use cases like OpenAI itself. When you upload a document and you ask a question, they use this technique called RAG to give you the answer. If you know about Perplexity, they also use the same technique called RAG. They do a Google search about anything, or let's say you asked a query, uh, can you tell me about this? So they will do a Google search, which will give them some documents, right? And then by reading these documents, they will generate an answer for your search query, right? Perplexity also works like that. If you know about Cursor or Devin, they all do the same. If you remember, if we have used Cursor, what it does, it goes through all the code that you have, and then you can ask anything about the code, or you can ask it to make some change. So what it does, it has all the code in your context, so all your code in its context, and that's how it is able to answer such specific answers, and it is able to fix your specific issues. So this is the advantage of using RAG, which is there in almost every application that we use. Cursor, GitHub Copilot, or Perplexity, Devin, everything is using RAG somewhere behind the scene, right? Now let's try to understand the basic steps of what happens behind the scene of a RAG. Let's say you are Amazon, right? You gave some documents, right? You have like you gave it a document of, let's say, 200 pages, right, which has everything about policy. Then you gave another document of everything about orders. Then you gave another document of 100 pages, let's say this is of 100 pages, where you are talking about something else, refund, right? Okay, now we are just trying to see what happens behind the scene of a RAG, right? And now user will give a query. Can you tell me about the cancellation policy? Now, what happens in RAG technique is it will try to fetch all the relevant context related to cancellation policy from all the documents that you have provided. Sorry, I forgot to add. The first thing that happens is it will break down your document into multiple chunks. In this case, let's say we have broken down into each page, one page into 200, similarly, one page into 100. What happens in RAG technique is it searches for all the relevant context related to cancellation policy. So it will say that, okay, this one has nothing about cancellation policy. This one has nothing about cancellation policy. This is the policy docs. So page number 5, 9, 15, 28, and 35 are talking about cancellation policy. This is the relevant context. This is then passed to your LLM using the user query. And then LLM generates an answer because it is just reading these 5 pages, right? And then it generates an answer that, okay, cancellation policies, this is this, and so on. You gave the document of at least 500 pages. It was able to discard all the non-relevant context, non-relevant data. It was able to fetch the top relevant data, relevant context, and then it generated some output for you. This is what happens, like this is an overview of the RAG technique. This is what we call RAG technique, where we had a user input. User gave an input to LLM, but using RAG technique, we fetched all the relevant context, right? And then generated an output for the user. This was just an overview. Now let's try to understand the exact steps, what happens in RAG. Okay, for that, I will refer to the Llama index documentation where they have a very good diagram where to explain the same thing, right? But the important steps involved in RAG are loading the data, then indexing, storing, querying, evaluation. What are these steps? Let's try to understand them one by one. The first step is loading the data, where you load all the data that you have. We have some PDF of 100 pages. You have a web page. You have a Google Docs. You have a sheet. You will put everything in, you will load all the data first, right? And then what happens next is indexing. So when you store all the data, these are broken down into smaller chunks. Okay, smaller chunks, like you can consider one paragraph as one chunk or some block of text as one chunk, right? These are broken down into chunks, and then these are stored in the form of vectors, right? And once we have stored everything in the form of vectors, these are also called vector embeddings. And then once user gives any query, we go to this vector store and find relevant context. Okay, out of all the data stored in this vector store, we'll find relevant context. And once we have relevant context, we'll pass the relevant context plus the user input to the LLM. And that's how we'll get our output from the LLM. Is this clear? The first step was loading all the data. Then we broke that data into smaller chunks. And then we converted this data into vector embeddings and stored it into a vector store. And then when user gave us a query, we searched for relevant context from this vector store and fetched all the relevant context and then passed that context plus input to LLM. And that's how we got our output. Now, these are the building blocks of a RAG pipeline, right? And if you are not able to understand anything here, like how to load a data, how to break it down into chunks, what is vector embedding, how all these things are happening, we are going to cover each and everything in the coming videos. We are going to cover loading, embedding, and chunking, and vector embedding, and everything else in the coming videos. I think that was all for this session where we covered what is RAG, why do we need RAG, what problem RAG solves, and an overall overview of RAG technique. And then we also went in depth, like what actually happens in the RAG technique. So that was all for this session. In the next session, we are going to cover embeddings and similarity search. When you have a smaller chunk in your hand, what happens next? Like what is embedding, how it is stored, and how do we do that similarity search? Like when user will give a query, how similarity search will happen. All those things we are going to cover in the next video. And then we'll also cover introduction to vector databases in the next video, and we'll build the whole RAG pipeline in this module. So make sure you subscribe to the channel and share this video with your friends. And don't forget to write in the comments whether you like the video or you disliked it or whatever you think, make sure you do that in the comment section. Thank you everyone for watching.